3, 6, 9, 12, so on. And a geometric sequence is 2, 4, 8, 16, and so on. Yeah, there you go. Very good. So, yes. For arithmetic sequence, some of the terminology we're dealing with, this change here, this plus 3 is a constant. We use D for difference. You see this letter is D. So in this case, D is 3. The difference is 3 each time. Yes?
Do we have to remember like the B2A?
No, that stuff is gone. Yeah. You have to remember very little for IB maths. You get all the formulas in the formula booklet, which I'll give to you this week because we're going to need it for this. Geometric then, there's a multiplication. There's a multiplication of 2. Yeah. So we refer to it as a ratio. One is twice as big. So ratio is used for, so or is 2 here. So there's something interesting. If this sequence was in reverse, what would the ratio be?
1/2.
Yeah. So the ratio, the ratio is a half. Yeah, right. The ratio is a fraction. Yeah, it's going down. Okay, so the first term in a sequence like this is referred to as U1, and it would also be for a geometric, and so on and so forth. Yes, and then the general term is called UN. We refer to as the general term, or sometimes that can be called the nth term, which we used in GCSE a little bit. And they both use UN for that general term. To prove something is arithmetic, if any two subtracted from each other gives the same answer, that means it is arithmetic. So for instance, U3 take away U2 is the same as or equal to U2 take away U1, then the common difference is the same. And you've proved it then. So you proved that the difference here is equal to the difference there. In other words, 9 take away 6 is 3, 6 take away 3 is also 3, so the common difference is the same, so we proved that something is arithmetic. To prove geometric, very similar. U2 divided by U1, if that's the same as U3 divided by U2, the common ratio is the same. Okay. And to find that difference, well, to find any difference, you just subtract two terms and you get the difference. To find any different or any ratio, just divide any two terms and you should be able to get the ratio. Okay. There are some formulas that are in our formula booklet that are quite useful to know. Not those ones here. You will see that the general term, the nth term, has a formula which is pretty easy to. This is a general term formula, so you don't have to learn off how to get the sequence of an arithmetic sequence anymore. And the geometric one, which I think we did in GCSE anyway, I used this one. Wait, not that. This. UN is the first term and the ratio n minus 1. So they are given to you. They're quite logical. This is just, the general term is use the first term, and if you know what the difference is, you can find out how many it is down the line. The number of terms plus 1 differences. And this one is how many times do I need to multiply the ratio to get the next one. So you see, I'm multiplying the ratio, same constant ratio. So the fourth term is got by 3 multiplications of the ratio, so 1 less than the number of terms, if that makes sense. Okay, so let's look at specifically kind of IB style questions of arithmetic sequences first. Now that we have something to go off. how do we show that or prove that a sequence is arithmetic? So we're dealing with this new sequence, 2, 9, 16, 23, and 30. So to show that it's, to show that it is arithmetic, I would say, all right, u2 minus u1 gives me a difference. So u2 is 9, take away 2 is 7. And then I'll do u3, take away u2. It's not very exciting stuff, but 23, or that's not u3. 16, take away 9 is also 7. Therefore, it is arithmetic. Now, if you've never seen those 3 dots together, they're not 3 dots. That means therefore. So you kind of proved it. So the difference is the same for both. That's a long way of doing it. It's possible they could ask you that in an exam question, so it's good to just remember it is quite logical. Part B then, find the formula for the general term. So that's, here is our general term formula. So un is the first term, u1, 2, in this case, plus n plus 1 times the difference. And the difference is 7. And I would probably tidy this up. We did this a little bit differently from year 7 on. We would talk about, okay, what's the jump each time, or what's the addition each time? Oh, it's adding 7 each time. That means a repeated multiplication of 7 must be in the formula if we're constantly adding 7. So that's 7 times the number. And then you would think about what the constant term would be.
No, it's
Something's wrong. It's n minus 1, isn't it? Why have I taken? I was like, this is not right. So it's minus 5. The formula was wrong. Okay, yeah. So it's constant difference. So you go back 1. You go back 1 to find what that initial term would be, or the constant term. 7n minus 5. Sorry, change that formula. I wrote it down wrong. Okay, so that's very straightforward questions to start off with, even though I got one of them wrong. Now, problem solving is where it's at. That's more likely the question, which is like in question 2 and 3 here. I'm just going to get rid of this. So question 2 presents find k given that 3k plus 1. K. What?
No, actually, she did it with us.
Oh, you've done it already, yeah. Are consecutive terms in an arithmetic sequence. So if they're consecutive, the first thing I go to is the fact that the difference would be the same. The difference would be the same in each one. So what could I do? I could say that this, take away this, gives that answer. K, take away 3k plus 1 will be the same as this, take away this. Yes? Minus 3, take away k. And I've set up an equation with only k and that I can solve. So I will solve. K minus 3k minus 1, applying that minus in, and then arrange the k's in whatever way you want. I think this is negative 2k. Add it to both sides. Okay, I'll do it. So maybe add 2k to both sides. What's that? Plus k. I think if we add 3 over, we get k to be 2. So do that, Priyanka? Yeah. Okay. Insert 4 numbers between 3 and 12, so all 6 numbers are in an arithmetic sequence. That's the second question. Oh, the third question. So insert 4 numbers between 3 and 12. I like to draw this out. You don't have to. But just so we get the correct number of differences between the two. So there's 4 numbers between 3 and 12, and all 6 numbers then form an arithmetic sequence. So the only thing we have to go on an arithmetic sequence, and this comes up a lot, is that there is a common difference. The common difference is always the same. So if I add a number, I know it's the same number if it is arithmetic all the way along. And now I know that there are 5 differences between 3 and 12, yeah? Not 4. There's 4 numbers, but 5 differences. So I know that 3 plus 5 differences will give me 12, whatever the difference is. So that means 5 differences must equal 9, which means a difference is 9 over 5, a decimal. Or if you like, decimals 1.8, I think. So that means insert the 4 numbers, you just add 1.8 each time, and you'll have the 4 numbers. Okay? Let's look at examples of geometric questions. Or maybe you do a few arithmetic first, actually, rather than go to geometric. Here's some arithmetic questions. And then we'll do geometric in a few minutes. You probably won't have time to do